Hey guys, welcome to Cars and Health Bars. On today's episode, I have my long-awaited guest, Brian Tooley of Brian Tooley Racing in Bardstown, Kentucky. With that being said, guys, let's get right into it. All right, of course, today we have with us Brian Tooley of BTR. Brian, how are you doing today?
Great. How are you guys?
Fantastic.
Awesome. Excited to get your head.
Yeah,
Me too.
You've been a desired guest, at least for me. You know, whenever we went to your Cars and Coffee, I was just blown away by the machining, and of course, I knew about you prior because of your blocks, your heads, your cams, of course. But I was just blown away by what you have built over there in Bardstown, and I just kind of want the listener to get filled in on kind of your story on how you started out and all that interesting stuff.
Yeah, well, I think it's an interesting story. Of course, I think everybody's got a story thinks it's interesting. But the big thing with BTR right now is the fact that it's been less than 10 years since I moved out of my basement.
Wow.
Right.
That is crazy.
45,000 square feet, over 60 employees, and but there was an interview done on the guy that invented Segway one time.
Yeah.
And he said it only took me 20 years to become an overnight success.
Wow.
And I have the exact same story because I started my first business in 1993.
Wow.
Was that total engine airflow or?
Yes.
Yeah.
Yes, exactly. So, so it's a very similar story, right? I started that in 1993. By 2001, I bought a 5-axis CNC. It was pretty successful. I was one of the first shops in the country with a true 5-axis simultaneous CNC. I was doing work for Texas Speed, Proline Racing, Bischoff Engine Service. I mean, you name it. I was porting heads for everyone. Our CNC ran 24/7.
Wow. Yeah, you got to have those
really,
machines pay for themselves. They're very expensive.
Yeah, and it it definitely paid for itself. And so that was 2001 when I bought that machine, and then by 2003, Summit Racing, TrickFlow kind of came knocking. Now, some background there, I'll try to tile this together and make it cohesive. So when I started Total Airflow in 1993, around 1996, I decided to do one thing and do it better than anyone. And quite honestly, I was at church one Sunday, and the pastor, there's part of the Bible that basically says that, right? Do one thing and do it better than anyone. And I decided that I was going to port twisted wedge forward heads better than anyone in the country. And I spent about a week porting and flowing and praying on a twisted wedge forward head that I was hacking on. And I was hacking on it because I didn't have anything else in my little shop to actually port at that point. And just a month or two later, I was at PRI. Right, so it's 1996, PRI, and I go to the TrickFlow booth and I see Rick Smith for the first time. Rick Smith is the founder of TrickFlow.
Yeah.
Right, started in the 80s, sold it to Summit in 93. He was a rock star in the 90s, and in the cylinder head industry. And so met him in 96. I'm at the TrickFlow booth, and he's surrounded by a crowd of people, and he's talking about the new Twisted Wedge R forward head, and he said, "Yeah, we have it flowing 270 at 400 lift." And I spoke up. I said, I had the Twisted Wedge street head flowing that. And at first, he kind of crinkled his face like he wanted to say BS. Then you could tell the epiphany hit his brain, and he's like, "You couldn't send me that head, could you?" And I said, "Sure." And so I sent that head to TrickFlow, and it was the highest flowing Twisted Wedge forward head they'd ever seen. And so they tried to hire me in 96, and they tried to hire me again around 2000. And by 2003, TrickFlow was kind of getting crushed because AFR had brought their CNC porting of their heads in-house. Edelbrock was using a company whose name escapes me now. Canfield was using, somebody. So pretty much, Dart was maybe in-house. So everyone out there was offering their own head CNC ported except for TrickFlow.
Yeah, so they're kind of falling behind.
2000. Yeah, absolutely. And in 2003, we had a stellar year. I was, typical small business owner. I went and bought me a brand new diesel dually pickup truck and a brand new enclosed trailer and a Corvette and went nines. And, we, we had a good year. And, when the trick flow manager saw me, ironically, PRI, 2003, and he said, "How's business?" And I told him, I said, "Man, we're porting LS heads by the pallets, running this machine 24/7. We are just killing it." And, he kind of hung his head. I was like, "How are you guys doing?" He said, "Well, we're not doing that good, right?" And he said, "We really need your expertise." And I said, "Well, there's one way to get it. It'd be by the business." And so he had me shoot him a price, and I shot him a price, and they did some due diligence and bought it. And then so in November 2004, we moved Total Engineer Flow to Talmadge, Ohio, where Trick Flow Summit is. And so that was the start of me working for those guys and my little team, developing all of their CNC ported heads.
Yeah.
So I personally did all the digitizing, programming. I had 4 CNCs that I had to that I had under my purview to keep up with the CNC porting production.
Wow.
And it was very educational.
I could say
Right.
so. A lot of self-learning, especially, I mean, were you running it all by yourself back then?
I was running the 4 CNCs that ported all of the heads. Yeah, I did 100% of the digitizing CNC program on those 4 CNCs.
Wow. That's incredible.
And I tell everyone, metaphorically speaking, I went to Summit with probably not even a complete bachelor's degree and left with a master's.
That's incredible.
Yeah.
Make no mistake about it. What I learned in the 6 years I worked for Summit Racing is a very big part of what has made BTR what it is today.
Wow, I didn't know that.
Right. Yeah, because I mean, just the valve spring thing, right? We developed that platinum dual valve spring at Trick Flow in 2005. And ironically, when I was leaving in 2010, they were looking at changing spring vendors. We had sold that platinum spring for 5 years without a single failure.
Wow.
And the spring vendor they were looking at changing to had a history of failures with comp. They actually made the 918 Beehive springs for comp. And I told them, I said, you guys would be crazy to switch spring vendors. And I left and they switched. And, and that's what, and then, I was, under a 2-year non-compete with Summit. And so I was doing day trading. I got my real estate license. I was building engines. I was porting heads. I was doing anything to make money. So if you guys ever need $2 turned into one, I'm your huckleberry when it comes to day trading. So yeah, the good Lord steered me in the direction not to go, I think, with that. But anyway.
So you went from
I'm getting a bit.
You went from your four mills to what do you have now at your Bardstown facilities? How many machines do you know off the top of your head that you have in operation now?
CNCs, I think we have, if you want to say everything that's a CNC, I think we have maybe 8. Because we have the Mazak, which is an 18 pallet pull CNC, right?
Yeah.
5-axis CNC. Yeah. We have the Haas 5-axis CNC. We have a Takumi 3-axis CNC that we cut patterns on. We have a Herco 4-axis CNC that we machine the blocks on. We have 2 Star Swiss turn machines that we machine retainers on. We have a Rottler CNC home, and then we have a Neuen CNC seat and guide machine.
Wow. I was just blown away by the Mazak alone.
That's a very impressive piece of equipment, isn't it?
Yes.
Well, I actually left out the most expensive CNC, the CNC cam grinder.
Oh, yeah, that I've never seen one in person, and whenever you showed us that, I was like, just seeing it all in person is so much different than seeing it in video. It's just incredible how. I mean, even what goes into the programming of each belt going in at a particular time, and it's just I can't imagine. I'm sure you have an amazing team there of programmers.
Yeah, the grinding wheel.
Yeah.
It's got a CBD grinding wheel, CBN grinding wheel, and that is an incredible machine. and they've developed software in just the last few years that actually speeds up the grinding process with less chance of burning the cam lobe, because if you're not careful when you grind a cam, you can actually burn the surface, and a burn actually anneals the steel and makes it soft,
Oh wow.
right?
Yeah.
Yeah, and when you see a cam lobe that, some people say it's spalling, some people say it's flaking, you hear it called all kinds of things. Well, that's actually where you've annealed the surface of the lobe, and that material is soft, and it can actually start flaking off,
Hmm.
right? And
Yeah.
and so this new software that runs the feed and speed of that CNC, because not only does the grinding wheel speed vary, but the speed of that the camshaft is turning varies as it's grinding.
Right.
And yeah, so the two of those working together, has increased you know, the speed at which that thing can grind a cam.
What
And
what's the
then
uh what's the grind time on one of those cams? Does it just vary depending on what kind of grind you're going for?
we, we don't really talk about that much in public.
Oh, okay, I got you. I
And,
understand
and,
that.
and, and I'll give you some idea. Most people out there grinding cams on a CNC cam grinder, they spend about 30 minutes grinding a cam,
Uh-huh.
and we spend significantly less time than that.
Wow. That's incredible. I mean,
Yeah.
cams have got to be. I mean, just from the outside looking in and here, originally hearing about BTR is like that's all people talk about is your camshafts because that's what everybody's putting in. Your Truck Norris cam is so insanely popular, and even your Red Hot cam, I'm starting to hear more and more about
Yeah.
of locals running it.
Yeah. It's a very good cam for a small cam,
Yeah, definitely.
you know. Yeah.
I think my favorite machine that you all have is probably that Spintron.
Yeah. Yeah,
That
that's
thing's
a
cool.
yeah. We actually bought the Spintron company.
Really? Okay.
Yeah, race winning brands that was part of Diamond Trend, that whole deal that Bob Fox owned, and they didn't have a lot of use for Spintron, and they actually sold it to us. So we're technically the owners. We're not currently providing any support for it, but even that in itself is almost amazing because they tell everyone to call us, and it's just like there was a couple months ago, the guy that runs the 4 Spintrons at Roush Racing contacted me. He's like, "Hey, I need this." I was like, "Well, quite honestly, not in a position to help you today." But then that led into an hour and a half phone conversation, about this guy that's been at Roush for 20, 25 years, which was an amazing conversation in itself.
Yeah.
I bet.
Um, but that Spintron, everyone out there that's developing camshafts without a Spintron and without an engine dyno, and they are at a huge, huge disadvantage.
Yeah, I would say so. That thing really looks like it helps out a lot.
It does, because it really equates to durability, right?
Yeah.
Stability on the Spintron equates to long-term durability of the valve train. And, we used to run durability testing at Trick Flow and even at Holly when I was there in the 90s. And when you start doing 24 and 48 hour, wide open throttle, continuous durability test, that is brutal durability testing. And that's really nothing compared to, the real life cycle of an engine, you
Yeah.
know? And so the ability to, spin up all these different parts and look and learn, and all these things that you assume are true, you find out are false. Push rod diameter, 3-piece push rods. This is one of the best things that I've seen, because we thought we were going to be cool and come out with our own 3-piece push rods like a man or something, right?
Yeah.
It was 4 grams heavier than a swedged in push rod like we sell today,
Yeah.
and that 4 grams hurt the trace on the Spintron.
Wow.
Yeah, I bet it was noticeable for sure.
Yeah, I mean it was not as good. And then like everybody runs bigger and bigger push rods, right? Because everybody says that weight doesn't matter on the push rod side of the valve train. Well, by the time, like, 11/32 is a good upgrade from a 5/16 push rod and an LS, but by the time you get to 3/8, it's now too heavy. So a 3/8 is not as good as 11/32.
How much difference do you see between like 11/32 and 3/8?
The actual closing bounce, I don't recall. I mean, it's measurable. It's a couple of
Yeah.
thousandths difference in closing bounce. Of course, that's the main thing we focus on, right? It's closing
Yeah.
bounce. Um, so yeah, I mean, there's just so many things that you hear about valve train that when you actually have a spintron, you do the testing, you find out are all false.
Wow.
Yeah. Yeah, and just, developing cam lobes and having different thoughts. And I'll be honest with you, I tell everybody in 2018, in spring of 2018, when we bought that same lobe development software that Comp Cams uses, I told myself it's going to be 15 to 20 years before we're probably as good as them. And by January 2020, we were as good or slightly better on the Spintron and Engine Dyno. And by mid 2021, we were significantly better on both.
Wow.
And from my perspective, I didn't think we would ever achieve that. Ever. I mean, I was hoping to be as good in 15 or 20 years.
Yeah, anymore, I hear of the older guys running comp cams, but anymore, anytime I hear of somebody doing a camshaft, it's either you guys or Texas Speed. That seems to be the two go-to camshafts right now for LSs.
Yeah, and what Texas Speed has done very well is marketing, and they were also out there first, right? I mean,
Yeah, they were definitely early.
yeah, I mean they were, 10 years ahead of me. I mean, right? I was porting heads for them in, I don't know, 2002, 2003, and then I didn't start this business until 2012. So, so they obviously had CNC cam grinding in house before we did, and all sorts of things. But where they kind of went wrong, not to throw my competition under the bus right here on the podcast, but they do not develop lobes in house, and they do not have a spintron.
Wow.
Yeah, I really feel like that is hurting them, not having a spintron.
Absolutely, because we do the testing and we know how good or bad their stuff is, and it's rather shocking.
Yeah, I originally went with a Texas Speed cam on my car, and after seeing y'all's spintron video, I immediately switched over to I'm gonna run y'all's cam.
It's the best, and there's so many aspects of making a great cam or the best cam, because it really starts at the cam core.
Yeah.
Right. And goes all the way up from there. And I would like to speak about cam cores, because a lot of people don't understand that all of us out here grinding camshafts, we all start with this thing called a UGL, what they call an unground lobe cam.
Yeah.
And that UGL, most everyone uses a generic UGL. And so the cam core supplier in Michigan, because there's 3 of them up there, they will try to heat treat those cam cores about 4 millimeters deep, and then leave upwards of 2 millimeter of material to grind off. Right.
Yeah.
Well, they'll try to grind literally 100,000 different combinations of intake duration, exhaust duration, lobe separation, the center lines, with just 10, 15, 20 UGLs. Okay. Well, that causes it causes several problems. Number one, when you try to heat treat that deep, it's almost like over baking your brownies or your cookies, right? It can get brittle.
Yeah.
And we've had the entire nose of a lobe fall off of 2 camshafts, for example.
Dang.
Golly.
It's the entire nose fall off. Right?
Wow.
And yeah, we've seen, like on a Gen 5 cam, the number 2 bearing journal where you had the oil annulus. We saw the entire front of those break off like a wedding ring.
Jeez.
That is crazy.
Yeah, and all of that is from trying to put too much heat treat in that cam core. Well, the way we do it is we do what's called a specialty UGL, which is where we have the special UGL made for every different cam that we grind. Okay.
Yeah.
Now, the heat treat is only 3 millimeter, but there's only a 0.5 millimeter of stock left on the cam to grind off. Right. So you don't have the stresses and the brittleness of a generic UGL, but then you also grind the cam much faster because it has less material to grind off.
Right.
and you
Yeah.
have way less chances of grinding through the heat treat, which is something that we see over and over, with one camshaft supplier out there. They'll grind through heat treat all the time, which is shocking to me.
Yeah,
It's
that
just
is.
it's just unbelievable. They spend 2 to 3 times as much time grinding it as they could if they just bought specialty UGLs,
Yeah.
and grind through the heat treat all at the same time.
Yeah.
So just the way we do our cam cores is unique. And of course, yeah, we have, 60, plus different part numbers of UGLs or specialty UGLs. And the problem with a specialty UGL is you have to order a minimum of 100 at a time, right?
Wow.
Yeah.
So a lot of people don't want to carry that much inventory. But from my perspective, if you can grind the cam in half the time or a third of the time, you could pay for the inventory.
Right.
Yeah, I agree.
And then the customer ends up with a better part.
Both
And
parties
then,
win.
yeah, so it's just like, so from my perspective, to have the best cam cores with the best lobe designs, the best cam grinding, because the Landis LT1E CNC, there's nothing better in the country for grinding a camshaft. It is the best CNC you can buy, right? The best cams from a cam timing event standpoint, that being the open close events, and then also the best cam finishing, because we haven't really even touched on cam finishing, right? We do isotropic or room finishing on our camshafts, right?
Yeah.
There's only 2 of us in the entire country that do that,
Yeah.
and everyone else sands their cams. And sanding a cam isn't nearly as good as isotropic or rim finishing. So when you can have the best cam core, the best lobe design, the best cam grinding, the best finishing, the best cam timing events all at the same time, I mean it's unbelievable from my perspective. If you'd have told me 5.5 years ago that we would have the best of all of those, I would say, how's that possible? That's like going from 0 to 100 in a second. How's that even possible?
Yeah, it's like
Yeah.
you said, Texas Speed did, they definitely have the longevity, especially over you guys, but the amount of catch up that you guys have done is incredible. And that kind of leads me into my next point. I kind of wanted to talk about PRI a little bit. For the first day, we struggled finding you a little bit. I was trying to search through the map, and it's such a large map. And I was like, oh, there's Brian. I was like, oh, he's kind of tucked in the corner there a little bit. But oh my gosh, the crowd we found whenever we finally got back there to you all, your booth was buzzing the whole entire time. And
yeah, it was pretty busy.
So were you waited until PRI to unveil that new head, didn't you?
We actually took the raw casting to PRI last year.
Oh wow, okay.
But we only showed it to a few people, a few industry insider people. So that was brand new for the show. We really didn't talk about it. We really don't like taking products to the show unless they're ready to sell.
Yeah.
So we really didn't talk about it that much even during the show. I don't feel like or maybe my marketing guy did. But from my perspective, I didn't want to hype it up too much because it wasn't on the shelf.
Yeah, that's the first thing we started doing. We were.
What's that?
When can we expect to see that on shelf?
I'm hoping April. We unfortunately Thursday or Friday of the show we received the quote back from the foundry that we wanted to cast them at, and the quote was not favorable.
So is it a sand cast or a permacast? I didn't notice.
So the castings we had at the show and the castings we've had on the dyno, those were all made from 3D printed sand cores.
Okay.
For production, we wanted to use permanent mold tooling.
Okay, yeah.
Yeah, which is the way to make a cylinder head, because you just end up with a better, denser casting. That's just it's more expensive tooling, but much better in product. And then we're also doing some unique things with the water jacket that we're not talking about.
I
But
noticed.
but yeah, one thing you notice when you look at it is all the water holes are round,
Uh-huh.
right? And we did that because it would make it
Strength, I'm
easy.
guessing.
What's that?
Is it I was gonna say, is that for strength or?
It's honestly for dry decking, and you could use it for strength if someone wanted, right?
Yeah.
Because if someone wanted to, because when you look at like the lower water holes on a head gasket, and those holes are like the 1/8 inch in diameter,
Yeah.
right? So you could literally plug those holes, with aluminum or steel plug or whatever material you wanted to, and then drill the corresponding size hole, to make that much more rigid. But the reason we really did it for is ease of dry decking. Because if you have a drill and a tap, you can literally dry deck those heads in your garage.
Wow,
Yeah.
that's nice.
Right? Yeah, because typically you have to weld the castings up, right? You have to weld all those water ports up to dry deck them.
Yeah. I was
So
gonna ask you a little more about those heads. I don't know if you're wanting to
sure,
divulge a lot of info now or not.
I can try.
I noticed the canted valve design too, and
Yeah.
the smaller valve too. The LT1 valve is a little smaller than the LS3.
Yep.
I was just
Yeah.
curious of why y'all chose that design. I'm sure you saw
Sure.
benefits from it. I noticed the intake valve looked a lot straighter than an LS3 valve, or sorry, runner.
It is. It's a very, very straight runner, which obviously helps power production. But yeah, let's talk about smaller valves. So there's several advantages to that LT1 valve, um, compared to what a lot of aftermarket heads are produced with. So when you get into these larger head diameter valves, 2 and 65 and larger on these LS3
Yeah.
and LS7 heads, most of them are solid stem valves, and they're in the 110 to 120 gram range.
Yeah.
That's a very heavy valve. And on our Spintron, it's like the titanium OE valves, and even LS3 hollow stem that are like
Yeah.
89 grams. Titanium stuff that's all the way down in the 70s. LS6 valves that's down in the 70s, and then solid stem LS1s that are about 100 grams. You Spintron all of that stuff in that 70 some to 100 gram range. All that stuff is pretty good. And then whenever you get to, let's say, an L99 intake valve that's 110 grams,
Yeah.
that valve's pretty unhappy. And then by the time you get to all these aftermarket stainless LS7 valves, a lot of the aftermarket LS3 valves, an LSA intake valve is 120 grams. By the
Sheesh.
time you by the time you get to 120 gram intake valve weight, that valve train is extremely pissed off.
I bet.
It is like flipping a switch almost when you go from 100 grams to 110 and 120. And so we knew we wanted a hollow stem valve. And when you look at just the power production we've made, our LS3 with stock heads and stock intake makes 570 horsepower. Our LT1 engine, we ultimately made 740.
Yeah.
God.
Both of them 6.2 liter engines. Both of them
That's a
running pump V85. Both of them hydraulic roller with stock rockers, right? Of course, obviously, a lot of that power production with the Gen 5 comes from the direct
sin.
injection. A lot of that, 60 horsepower, that's just from the direct injection, but a lot of that comes from the cylinder head, right? And
Yeah.
so when you look at intake, when you look at airflow of a hydraulic roller cylinder head, if you want to make power, you focus on coefficient of discharge.
Yeah.
Coefficient of discharge formula is intake valve diameter times pi, which gives you circumference, times lift, which gives you curtain area. And
Yeah.
so at each lift point, you take the airflow divided by the valve curtain area. And that unit of measure, not only is that an efficiency number, but that's also CFM per square inch. So it's
Yeah.
actually a velocity number as well. Okay, right? CFM per square inch.
Yep.
Now, if you want to make a really powerful hydraulic roller street strip head, you focus on 100 through 500 lift.
Yeah.
You don't even pay attention to 6 or 7.
Yeah. Because you're barely touching them.
You barely touch them. Exactly. But what you want at those points is not what everybody thinks. Because at 100 lift, you want that thing to flow the least amount of air possible.
Because you want to build up a air in the runner, is what I'm going to guess.
Because whenever the intake valve opens and the cylinder is still blowing down, it's still blowing exhaust out the exhaust port.
Yeah.
The less that intake flows at low lift, the less intake reversion you get at idle, and the more power you make at peak horsepower. Because anything you do to pump exhaust gas back into that intake port is lost power, bad drivability, bad idle.
Yeah.
Nothing good comes from pushing
hot air back.
anything back. Anything, right? I mean, you want that intake valve to act like a check valve against reversion at all times, right? Whether it's during overlap or whether it's the end of the intake cycle, right? And so, but the next thing you want is you want the head to flow as much air as possible at 3, 4, and 500. Well, because 400 is in the middle of 300 and 500 lift, we really focus on 400 lift, okay? And to quantify this, I'll tell you a story from 2005. We're at Trick Flow. We're developing, we just finished the 215 cathedral port heads. We're now developing the 225 heads, cathedral port heads, for the LS2 engine, right? It's 2005, right? LS2 just came out in 2005 Corvette. Brand new car, brand new engine. So we are developing this 225 LS2 head on a 4-inch bore, and we tested a 205 valve and a 208 valve, right? The 205 valve at 400 lift flowed 10 CFM more than the 208 valve. So we chose the 2050 valve. And we've also discovered that with these long runner LS6, LS2 fast type intakes, that a smaller exhaust valve would actually make more peak horsepower because it wouldn't over scavenge during overlap.
Right.
Okay, yeah.
And that's something I would like to reiterate. We use the smaller exhaust valve so it wouldn't over scavenge during overlap, because when you over scavenge the intake runner during overlap, you're blowing air that you really want to trap and burn out the exhaust. Okay. So we ended up with a 205 157 valve combination on this 225 Trick Flow head. Well, rather than the dyno guys at Trick Flow testing that head on an LS2, they instead built a 402. Right? They took a 4-inch bore block, put a 4-inch stroke crank in it, and tested it against an AFR 225 head that had 208 1600 valves. And I kind of cried foul, right? Because I was like, wait a minute. This thing was developed for an LS2 size engine, not a 402. And they said, we don't care. It needs to go head to head against the AFR 225, and we're going to see what it does on a 402.
Huh.
So they did the test, and the Trick Flow head made 20 horsepower more than that AFR 225.
Wow.
With smaller valves on both sides.
Yeah, I feel like there's a big misconception about bigger valves automatically equals more power in the head industry.
It's the biggest misconception in cylinder heads in the entire automotive performance aftermarket.
Yeah, I see heads like the Frankenstein M311s, and originally I thought they were a pretty good looking head, but then you see they got that bigger intake valve, and that really steered me away from them.
Yeah, I mean, I see, not to call them out, but like a Mass 305 head.
Yeah.
With that 2.25 intake valve. You see guys put those on, C6, Z06s, at least I saw it for years. And those heads dramatically underperformed.
Yeah.
You put them on a big engine, 440-some, 450-some cubic inch, and turn it 9,000. Now they would make power.
Yeah.
Because you could use the area, right? But on a hydraulic roller street strip engine, you don't really need area. You need efficiency. You need high velocity.
Yeah. That kind of makes me think of Coyotes for some reason.
Yeah, and 4-valve stuff is so different from 2-valve that it's hard to
really compare.
right?
Yeah, it's more apples to oranges.
Yeah, yeah. So I'll tell you another story about that 225 head. So now we released the head, right? And a guy in California had already made 480 the tires, which, believe it or not, was like one of the highest horsepower LS2 cars in the country in 2005.
Oh, wow.
And so we send him. I know, right? So we send him. Of course, that Fast 92 had just came out, so that was the best intake you could run on the engine. And so we sent him a set of heads, and he called me, and he was mad. He said, "Man, I just data logged this car. I'm moving less airflow through this engine than what I did with the Lingenfelter heads I just pulled off that had 205 1600 valves." And I said, "Okay, well, don't freak out just yet. Take it to the dyno. Call me back." Right?
Yeah.
But he was mad. So he calls me back. He said, "Well, I dynoed it." Awkward pause. And I'm like, "And?" He said, it made 507. I was like, "Wow, 27 real horsepower gain over the Lingenfelter heads. That's pretty good, right?" And he's, kind of still talking slow. He's like, I don't believe it. I don't understand it. And I said, "Well, understand that trapping and burning the air is what makes power, not what you blow out the exhaust port.
Yeah.
Blowing air out the exhaust port doesn't make power. It loses power, right?
Yeah.
And that's what's so important about understanding over scavenging in an internal combustion engine, right? You need proper scavenging, and obviously, as you put more and more intake manifold on an engine, it's less and less likely to be over scavenged. But properly controlling, the cylinder head, valve diameters, camshaft overlap, works with the intake manifold. I mean, everyone knows that whole package works together, but some people don't realize to the degree that it works together and how important, that is.
Right. I do want to hit on the Trinity a little bit before we get off here with you. I wanted to know kind of because the Trinity seems to be, again, like the go-to. It's really becoming the go-to intake whenever it comes to LS cars. Of course, Texas Speed does have theirs, but it does seem like I'm seeing more and more of the Trinity intakes. Can you kind of walk me through how you came up with that design and how you feel, it performs to the competition?
Sure, I'll be glad to. And honestly, this story goes back to 1993 when I was at Holley. The first project I got handed was a project for Mercury Marine. They had just released their first V6 fuel injected engine, or were about to release it, and they had uneven air fuel ratio on all 6 cylinders.
Dang.
And they couldn't understand it. And they came to Holley and they said, "We don't understand. We have 6-cylinder engine, 6 port injectors. Every cylinder has different air fuel ratio."
Uh-huh.
And of course, me being an airflow guy, of course, understanding, 1993, Holley's leasing my flow bench from me.
Jeez.
Okay, yeah.
Yeah, this is a true story, right? They're leasing my flow bench. And, me being the airflow guy, I'm like, well, clearly, if that's the case, then every cylinder is getting a different amount of airflow. And so I built a fixture to flow this intake manifold and flowed all 6 intake ports, and sure enough, all 6 flowed a different amount of air, right?
Yeah.
And so then we designed an intake manifold that had very equal distribution. And from that point forward, I spent a lot of time paying attention to distribution. Around 96, I had a top Ford racer, of course, I'm porting heads and doing intake manifolds and all this stuff through Total Engine Airflow. And he sent me a Victor Junior Ford intake, and he's like, "Here, weld the EFI bungs on this thing, and machine the fuel rails to fit and all that stuff." So I did all that for him.
Uh-huh.
And he sent it to me, and he said, "Look, we got this thing on the dyno." He said, "We actually have a trim box that we can trim fuel injectors up and down 10% each, right?" He said, "So we had this thing trimmed to where the end cylinders are trimmed down 10%, the center cylinders are trimmed up 10%, and we're doing plug readings, and we can see that our center cylinders are still running leaner than our end cylinders on a single 4-barrel Ford intake. He said, "What should I do?" I said, "I think you should pull the intake off and put it in a trash can." That's what I would do, right? Because he didn't ask me my opinion of putting, injectors in the intake. He just asked me to do it. And, so I've always, obviously I've done a lot with intakes over the last 30 years. At Trick Flow, we actually spent some time trying to better a fast intake for average power.
Yeah.
We couldn't do it. But what we did do is, I did some things where we, were modifying the entry of the runner into the plenum and showed more air on the flow bench and put it on the engine dyno, and it made less power everywhere. So that was kind of an epiphany for me, right? Because that gets into reflective wave. Okay.
Yeah.
So when you're designing an intake manifold, I mean, you want cylinder airflow distribution to be good, which the Trinity is excellent. It's really better than it should be. But when you look at the plenum, that maybe we should talk about airflow distribution in a typical, throttle body mount, an intake with a throttle body that is flowing air across the entry of the runners.
Yeah.
What typically happens is the opposite where everybody thinks. Everybody thinks, okay, those front runners are going to get the most air and the rear runners are going to get the least. Well, at wide open throttle, the velocity of air is so high that the air comes past the front runners and actually kind of starves the front runners for air, so they run richer. Then the air stacks up in the back of the plenum, and the rear cylinders get more air.
Yeah.
The real problem with that is the rear cylinders are also the hottest cylinders on the engine.
Yeah.
Right? So when you have the hottest cylinders getting the most amount of air, you have real problems. And that's why people, they tend to take out number 7, number 8 cylinders first.
Yeah.
And so when you look at that Trinity plenum, not only is the top of it tapered, down at the back, but if you look at the bottom side of it, the bottom side is actually tapered as it goes toward the rear of the plenum too.
I never noticed that. I did notice the top.
Yeah. So it's actually tapered top and bottom to restrict air toward the rear. And honestly, it was a swag, right? Scientific wild guess in case you didn't know what swag was.
Okay.
And and it was magic. I mean, that the Trinity LS3, for example, has as good of airflow distribution on an LS3 as our LS3 Trinity intake does. I mean, the equalizer intake.
Yeah.
The dual plenum type intake, which is really quite remarkable to have that good of distribution. Well, the other thing is people focus on that runner length. They say, oh, well, short runner, it's going to murder the torque. A runner that's longer is going to make, just kill it on torque.
Yeah.
And then they see the high ram comparisons where, it's like on the Gen 5 engine, at a couple of points, the torque curves touched, and then the Trinity surpassed it by 7,000. So they see a power curve like that, and they're a bit dumbfounded because they can't believe that it makes that much torque in comparison. But it's because there's more than just runner length that produces torque.
Yeah.
The reflective wave in the runner is what really produces torque.
Huh.
And there's more than just runner length that affects a reflective wave. Right?
Yeah.
And that's, I try really hard not to educate my competition. And so, so that's kind of all I'm going to say about that.
Completely understand.
But,
like I was saying, it seems like more and more people are starting to kind of bleed, BTR parts, especially the bolt-on parts, into their build, especially the LS crowd, the LS3 crowd in particular.
It's good stuff, but if it's a naturally aspirated hydraulic roller that you're turning 7,000 RPM, that's not the intake I would run.
Yeah.
Yeah.
It's not. I mean, I tell people all the time, they got a 5.3 or an LS1, and they're turning 7,000 RPM. I'm like, hey, buy a fast 102. That's
Yeah.
that's the intake to run. But for the guys that are boosted, which lots and lots of people are boosted these days, and most all of them that are boosted have all discovered the more RPM I turn this thing, the less likely I am to hurt the bottom end.
Yeah.
Right. From cylinder pressure.
Yeah.
And so they need intakes that turn RPM with boost, but they also have good distribution.
Right.
Right.
Mm-hmm.
Because it's ironic. I just was, I'm in GPI has a chat or whatever on Facebook, a group on Facebook that I'm on. And, we were just talking about this cylinder airflow distribution, and I posted a dyno graph of a short runner intake that had about a 1.5 AFR spread from the leanest cylinder at the leanest point to the richest cylinder at the richest point. And people don't realize, I mean, well, even a stock LS3 intake, it has a 1.5 AFR spread.
Yeah.
Stock, right? People don't realize that, what's really happening with air fuel ratio, and you have to have 8 wideband O2 sensors, one on each cylinder, to see that stuff. And quite frankly, most people with engine dynos, they just don't have the 8 wideband O2 capability.
Yeah, they'll just run one at a collector.
Yeah, they got one in each collector, and that's all they've got. Yeah. So the other thing we did was testing cross-sectional areas. Cross-sectional area taper, right? I mean, we would just take runners, we'd CNC them, and run them across the dyno.
Right.
Yeah.
And there's other aspects of the runner that we, physically machined in the runner and tested. And that's how we arrived at the runner length, taper, and cross-section that we have, because the runner length, cross-section, and taper that's in the Trinity is identical to the equalizer.
Okay, I did not know that.
Yeah.
A lot of people don't know that, but yeah, they're identical.
Wow.
Same runner. But the Trinity does make more power because, the equalizer, the airflow, flows in the bottom of the intake and then has to flow up, to the runners. And while that's great for distribution, it is somewhat restrictive for horsepower.
Yeah.
But, an equalizer intake, like the cathedral port intake at 7,500 RPM, the AFR spread is 0.5.
Dang, that's really good.
Yeah. If you saw all the stuff that we see, it's there's nothing better.
Yeah.
Right. So let's say you have a 5.3 on boost, and that equalizer cathedral, it's hard to beat, and it's going to help save an engine.
Yeah.
Because it's such even distribution, and because it's a 5.3 engine, it's not as restrictive as that intake would be on, larger engine. Even though that intake made, 2,200 horsepower on Kenny Dangler's 388, which was obviously a lot. That's a hydraulic roller 388.
Yeah.
So it's not like it's terrible, but the Trinity will make more power. Yeah, it just will, and with surprisingly good distribution.
Yeah. Well, Brian, I don't want to take up too much of your time. I do appreciate you coming on, and I do want to inform our fans where they can get some Brian Tooley products. I guess, of course, that would be BrianTooleyRacing.com, wouldn't it be?
Yes, sir. That's it.
All right, Brian. Well,
I had one more question.
Yeah, go for it.
Sure.
I was just curious, are y'all doing Cars and Coffee again this year?
Oh, yeah.
Yes, we are.
Yeah, that was probably one of my favorite. Of course, we're out of Bowling Green, so it's a little bit of a drive, but it is well worth it. So if you're listening and you enjoy going to Cars and Coffees, be sure to be watching out for Brian Tooley's, because there is always some crazy cars and builds out there.
Yep, lots of cool people hanging out for sure.
Definitely. Well, with that being said, guys, we will catch you guys in the next one. Hey guys, I hope you enjoyed the episode as much as we did. If you did, hop on over to our social media as well as Brian Tooley's and follow him. Keep up with what he's doing. He's doing a lot of stuff in the LS market. LS and LT market. You're not going to want to miss out. Also, like we said at the very end, Brian has the most killer cars and coffees around. You're not going to want to miss those. I'm telling you, if you've followed the show before, you've seen our brackets of the Brian Tooley cars and coffee, and it was bizarre. Like, by far the best cars and coffee we have around. And I again want to extend a huge thanks to Brian Tooley for coming on our podcast. A dream guest for me, so can put that in the books. So with that being said, guys, we'll catch you in the next one.